welcome to Joint Chemistry. Today we will do some examples of IUPAC nomenclature. In the previous video I discussed about the rule of the nomenclature, IUPAC nomenclature, and also the meter charge calculation. Okay, in this video we will do some examples of IUPAC nomenclature. Here I will also do the coordination number calculation and also the metal charge calculation. Okay, so let's start. At first, this is the complex, which is rhodium NCS whole 3, then NH3 whole 3. Okay, now here NCS, which is a isothiocyanide. Okay, now I told you in the first video why it is NCS isothiocyanide and when it is only thiocyanide. Okay, because it is an ambident ligand. So I told you every kind of ligands and their classifications and their examples and names. So you should go to my first video of coordination compound so that you will understand what I'm talking about. Now so it at first let's calculate its coordination number, which is Cn is. Now as you can see, into this coordination number there are 3 isothiocyanide and 3 amine, right? So the total is 6, so that's why the coordination number is 6. Coordination number is 6. Now how it is coordination number 6? So from the first video you will understand why it is 6. And let's calculate the charge. So let's say it is X, the charge of the rhodium is X. So X plus every NCS gives -1 charge. So there are 3 NCS, so 3 into -1. And amine is a neutral ligand, so it will donate only 0 charge. So there will be 3 into 0 is equal to the charge of this complex, which is, it is a neutral complex, so there is no charge outside of this complex, so that's why it is 0. So X 3 into -1 is equal to -3 plus 3 into 0 is equal to 0 is equal to 0. So X minus 3 is equal to 0, so X is equal to plus 3, right? So the charge of the rhodium is 3. Now let's write down its name. So its name is, first we will start from amine, so tri amine, then this tri isothiocyanide, then rhodium 3. Okay, so this is the name of this first complex. Now let's write the name of this complex. This is platinum En. En is a short form of ethylene diamine. The structure of ethylene diamine in the first video I showed you again. So this is the structure of the ethylene diamine, right? There is a ethylene having 1 and 2 position, 2 amine group. So if we calculate the metal charge of this one, so X plus ethylene diamine is a neutral ligand, so there will be no charge, so 0 into, there are 2 ethylene diamine, so 0 into 2 plus there is a Cl, each of the Cl donates -1 charge, so there will be 2 into -1 is equal to, there is no charge outside of this complex, there is 0. So X minus 2 into -1 is equal to -2 is equal to 0. So X is equal to 2, right? Or plus 2, same thing. So now let's write the name of this complex. Again the coordination number. Now let's talk about the coordination number. Now what is coordination number? The coordination number is number of the donor site of the ligands, the total number of the donor site of the ligands, okay, or total number of the donor atom, right? The total number of the donor atom into the coordination sphere. This is known as coordination number. I told you in the first video. Now here the 2 ethylene diamine is there, each of them has 2 donor sites, right? So total 2 ethylene diamine has 4 donor sites. and with 2 chlorine, so therefore their coordination number is 6. Okay, coordination number is 6, and so each of chlorine has 1 donor site and each of ethylene diamine has 2 donor site. So there is a 2 into 2 4, and each of them chlorine has 1 donor site, so there is a 2 into 1 2, so 4 plus 2 is a 6. I hope you can understand this. Now the name of this complex is dichlorido. Now what is chlorido? I told you in the first video, you should go and watch that video. Then bis, then in bracket ethylene diamine. See again, this is not a correct way to write IUPAC naming. The IUPAC naming should be in one word. Okay, there will be no break, no space. Okay, so if I do this, I'm starting from here to there so that it will be in a one line. Let's see, chlorido, then bis, okay, then ethylene diamine, then platinum 2. Okay, it's done, so we can cut it. Okay, so this is the name, it should be in a one line. Now there is another complex, the coordination number is 6. Why? Because we have to calculate the number of the donor atom into this square bracket, into this square coordination sphere. So here is the 6 water molecules, that's why this coordination number is 6. If we calculate the charge of this chromia, so X plus, now H2 is a neutral complex, neutral ligand, sorry, H2 is a neutral ligand, so it will contribute only 0 charge, so 0 into 6, and there are nitrate NO3, it has minus 1 charge. Okay, each of them donates minus 1 charge, so plus minus 1 into 3 is equal to 0. Overall this complex is 0 neutral, so that's why it is equal to 0. So X plus 0 minus 3, I think it's minus 1 into 3 is equal to minus 3 equal to 0. So X minus 3 is equal to 0. So X is equal to plus 3. So charge of the chromium is 3. Now the name is aqua. Then chromium. Okay. Then chromium. Then 3. We have to write down the charge of the metal after its name, 3. Then there will be space because it is on the ionization sphere, so we have to give a space between the coordination sphere name and the ionization sphere name. So after giving a space, this nitrate. Now you should know this, that we should not designate the number of the ligands outside of the coordination sphere. Okay, we really don't need to. We don't need to designate their number outside of this coordination sphere. So that's why it is only nitrate, not trinitrate or something. Why? Because after outside of this coordination sphere, we do not need to mention their number. Okay, we don't need to mention their number outside of this coordination sphere. Now for this one, the total coordination number is equal to the number of the donor atom inside this square bracket. So there are 4 NH3, 1 H2, 1 chlorine. So 4 plus 1 plus 1 is equal to 6. Now let's calculate the charge. So X plus 4 into 0 plus 1 H2 into 0. Why? Because both of them are neutral complex, so that's why they donated only neutral ligand, both of them are neutral ligands, so they only denote 0 charge. Then there are Cl, which donates -1 charge, only once here, so -1. Then there are two Cl outside of this coordination sphere, both of them, sorry, each of them denote -1, so -1 into 2 is equal to 0, right? So x plus 0 plus 0 minus 1 minus 2 minus 1 into 2 minus 2 is equal to 0. So x minus 3 is equal to 0. So x is equal to 3. Okay. Now let's write the name. It will be big little bit. So let's do this. Let's start from here. The name is, now it's amine. Let's start from amine. It is tetra amine. There will be no space. Aqua total number of donor sites. There is a methyl amine. The donor site is the nitrogen. There is one donor site, chlorine, one donor site, two amine. There are two donor sites. So 2 plus 1 plus 1 equals 4. So each contains 4 donor sites. That's why the coordinate number is 4. Now let's calculate the charge of the meter. X. Now x plus, now in chlorine it is -1 charge, so it will be -1 plus, it is the meter complex, methyl amine, it will be only 0 charge, so 0 plus, it is ammonia, it is a meter ligand, it will be 0 charge, so 0 into 2 plus, because there is a 1 here, it will be -1 charge, so -1 is equal to 0. So x -1 0 0 and then there is a -1 equal to 0. So x minus 2 is equal to 0 because minus minus is plus, so that's why x minus 2 is equal to 0. That means it is equal to plus 2. Right? I hope you can understand this. Now let's write it new. This is triamine, right? Because alphabetical order, amine comes first, then chloride, then in bracket, okay, in bracket, methyl, then bracket close, then platinum, then the charge of the metal is 3, then the metal is 3, then there will be a space, then 4. Right? So this is the way you can write IUPAC nomenclature. Now let's see. This is a complex ion. As you can see, it is a complex. Now the coordination number will be the number of the donor atomic sites of coordination square into 1 and 5 amino, so 5 plus 1 is equal to 6. Let's calculate the charge on the meter. So x -1 because chlorine donates -1 charge, ammonia is a meter ligand, donates 0, so x5 into 0 is equal to the charge of this complex ion. So the complex ion, this complex ion contains plus 2 charge, so overall summation of this charge will be plus 2. So x -1 is equal to plus 2. So x is equal to 2 plus 1. X is in the side, so -1 will be plus 1. So that's why it is plus 1. So x will be plus 2. provide. Then after that, within a space, you have to write ion, right? Because it is the ion, complex ion, that's why you have to write ion. Now there is another example, which is another complex ion containing -10 and it is 28, it is also has one that each of them, then it's -1 charge, right? It is a -1. Now let's calculate the charge of the Z. So X plus -1 into 4, right? Because each of them says -1, so total 4 NCS will connect -1 into 4. This is equal to the charge of the complex ion, which is -2. So X minus 4 is equal to -2. So X is equal to -2 plus 4 is equal to plus 2. Right? So the charge of the green is plus 2. Now let's write down its name. How it is named? It is extra iso cyanide. Okay? Iso cyanide. Cyanide. Zinc. Why zinc? Because it is something the negative charge. So the name of the metal is altered in the end with ATE. Okay, you have to add the ATE end of the name of the metal. So that's why it is not zinc, it is zinc. Okay, you have to write down this here. Then the charge of it metal is 3, and after giving a space is iron, right? Because of the iron. Now let's do another one. The provide ethylene diamine, 2 ethylene diamine, and there is a ONO. Ambident ligand of ambident ligand NO2, right? So the NO2 can donate from oxygen side, also from nitrogen side. When it is donated from oxygen side, it is denoted as a ONO. When it is denoted from nitrogen side, it is denoted as a normal NO2. So now it is ONO, and the meaning of this ONO is nitrogen. I already told you all of this in the first video of this chapter. If you have not watched that video, please go and watch that video. Okay? Now, what is the coordination number of this complex? The coordination number is each of the ethylene diamine. I already told you the structure of the ethylene diamine. This is the ethylene diamine. Each of the ethylene diamine contains 2 donors. So there is a 2 ethylene diamine. That's the total donor is a 4, and 1 donor considered from the ONO, and there is a 1 donor from CN. So the total is 4 plus 1 plus 1 is 6. Now the charge of this metal, right? Plus ethylene diamine is a neutral ligand, so it will be 0. Plus it is a ionic ligand, so there will be -1. Again, here is a ionic ligand, so again it will be -1. And outside of this coordination here, there is a CN, which is also considered -1, which is equal to 0. Right? It is 4 minus 6, right? Because it is 8 is equal to plus 6, right? This is equal to plus 6. Now let's write down the name of this complex. Now this is CH name. It has a CH name here, like this. First, it starts from slowly there, because alphabetical order C comes first. In alphabetical order, C comes first. And then here, it is slowly there, slow, there. Then that is ethylene diamine. Now why it is this specific is up, and why was this specific is added? We have to go back to the second video of this chapter. I told you can see 2 rule of IUPAC, and hydrogen atom. So we need two cyanide. That's why the coordination number is has coordination number 6. Now the charge of the metal. Now each of the sodium contributes plus 1 charge. So there is a plus 1 plus H plus each of the cyanide contribute minus 1 charge. So minus 1 into 2 is equal to 0 because there is no charge outside from this complex, so that's why it is 0. So now H plus 1 and there is a minus 1 into 2 is equal to minus 2 is equal to 0. So H minus 1 because plus minus is minus, so minus 1 is equal to 0. So H is equal to 1. So the charge of this complex is charge of this metal is 1. So the mean is sodium, then there is space, then di leader orange. Here is R8 orange, right? Dicyanide orange 1. So this is the IUPAC name of this complex. Now this is a special kind of coordination compound where the cationic part and anionic part both are coordination compounds. So as the rule of the IUPAC naming, we have to name first the cationic part, then the anionic part. So here this one is the cationic part and this one is the anionic part. If we write down the ions of this complex, so these are the ions. You can see the first one contains plus 2 charge, that's why it is cationic, and the second one contains minus 2 charge, that's why it is anionic. Okay. So we have to name of this first part, which is tetra amine platinum. Now the charge of this platinum is 2. Okay. So platinum 2. Then we have to give a space. Then write tetrafluorido. Platinate. Why it is platinate? Because this is a negative charge complex ion, so you have to in the name of the metal is take, right? Then its charge, this is 4. If you calculate the charge of this platinum, you will know that it is a 4 charge platinum and this one is a 2 charge platinum. Okay, so this is the name of this compound, coordination compound. So these are some examples of coordination compound. I hope you can understand it. Now please, if you have not watched the previous video, please go and watch those videos so you will get help to understand these examples. So in the next video I will talk about isomerism of coordination compound. So see you in next video. Please like, share and